Is there a quick way to work out the solution when dividing terms with the same base? If we look at the expression on the left, 2 to the power 5 divided by 2 to the power 3 in expanded form would look like this. We can see now that we can cancel 3 of the 2's from the numerator with the 3 2's in the denominator. And our answer would be, in index form, 2 squared. How does the power of 2 relate to the powers of 5 and 3 that we started with? Well, 2 to the power 5 take 3 is 2 squared. Does it work for other bases and other powers? If we look at the expression 7 to the power 4 divided by 7, again in expanded form, it would look like this. We can cancel one of the 7's in the numerator with the 7 in the denominator, and our answer would be 7 cubed. But we find that's actually 7 to the power 4 take 1. While there's no power on the 7 in the denominator, that's actually 7 to the power 1. Does this work for algebraic terms? Well, if we consider a to the power 5 divided by a to the power 3, again in expanded form, it would look like this. And we can cancel 3a's in the numerator with the 3a's in the denominator. And our answer would be a squared, or a to the 5 take 3. So in general, if we're dividing terms with the same base, we can subtract the powers. And this gives us the second index law. So for example, in expanded form, 5 to the power 4 divided by 5 to the power 3 would look like this. We can then cancel. Leaving us with 5 to the power 1, or 5. Using the index law, this would be 5 to the power 4 take 3, or 5 to the power 1, which is 5. Similarly, x to the power 5 divided by x to the power 2 would be x times x times x times x over x times x. We can cancel 2 of the x's in the numerator with the 2 in the denominator, and we find our answer is x cubed. Using the index law, that would be x to the power 5 take 2, or x to the power 3. When the expressions involve coefficients, we simplify those the way we would any fraction. So we know that 4 goes into 4 once, and into 12 3 times. We can then use our index law to work out the power of x. It's also possible just to cancel the x squared with the x to the power 5 and leave us with x to the power 3. In this problem, we can't simplify the 6 any further, and there's no way to simplify the x. However, we can cancel the y in the denominator with the y in the numerator to leave us with y squared. So the answer to this would be 6xy squared. In this expression, 8 goes into 8 once and into 24 3 times. We then have y cubed and y to the 7, which leaves us with y to the power 4. And we can simplify the z to the power of 4 with the z squared in the denominator. So that goes into once, and it goes into it, leaving z squared. So our answer would be 3 y to the 4 z squared. We can see this using the index law. So if we simplify the fraction, we end up with 3. Then it would be y to the 7 take 3, z to the 4 take 2. To give us the same answer, 3y to the 4 z squared. In this expression, 3 goes into 6 twice and into 15 5 times. We can see that a to the 7 will divide into a to the 11, and 11 takes 7 is 4. So in the numerator, we're left with 2a to the power 4, and in the denominator we have 5 times 1, or 5.